All right, hello everyone, this is Mr. Courage. I'm going to give you some help with our lesson today. We're talking about logarithms, which are the exact opposites of exponents. We've been doing a lot of problems that look like this. 2 to the third power makes 8. And we're going to do the reverse of it, saying right here that a log base 2 of 8, this 3 is needed to go 2 to the third power makes 8. So it's a different way to write it. It's kind of like forwards and backwards. I always think of it like we're doing sine and we're doing inverse sine, the reverses of each other. We can do logs and exponents in the same thing. All right, a couple sample problems here. If I have the log base 10 of 100, what number is that? Well, it asks this question down here. What is a logarithm? It says what exponent is required to go from the base to reach the value of a. So what exponent do we need here? Well, what exponent do we need here to go from a 10 up to a 100? Well, it's a second, it's a 2. And the way I like to remember this is I always draw letter E for exponents. Here I draw this letter E, and it's just from 10 to x to round, meaning that 10 is what power, 10 to what power makes 100? Well, you can see that has to be a 2, right? Because if I put a 2 in there, 10 to the second power equals 100, and that works. So that's what an exponent is. It asks, that's what a log is. It asks what exponent is needed to go from here to here. All right, let's do another one. What about log base 3 of 27? Well, what exponent do I need to take a 3 and make a 27? Well, I can rewrite it. 3x equals 27. 3 to the third power is 27. And all the problems that we're going to do today are easy enough. You'll be able to figure them out in your head. The other way to do that is to say this is 3 to the x. 27 is 3 to the third. So x is equal to 3. All right, what about log base 5 of 625? Well, again, what exponent do I need to take this 5 and turn it into a 625? Well, you can do the work. You should be thinking that 5 to the fourth is 625, so x is my exponent. That's the exponent we need to take a 5 to the fourth is 625. Exponents and logs are related this way. You can do some work with a calculator. We'll talk about the work with a calculator later. Everything we're going to do right now is should be done by hand. All right, so for your homework, you have this worksheet here, a bunch of multiple choice problems and their equations to solve. All right, equation number 1. It looks a lot worse than it is, but we are given this equation. And now what we have to do is solve for n. So we're going to do some algebra and get rid of everything around the letter n. Well, first off, we could add this 8 over to the side. And if I add that 8 over to that side, I have a negative 36. Then I could divide this 9 over there, and I would have log base 5. Negative 5 is 4. What did I do here? I added 8. I divided by negative 9, and now I'm here. So this is where we're going to convert from log to exponent. And it's the same logic. 5 to what exponent? Well, they tell us the exponent. So if I were to put this notation in here, 5 to the fourth power is this answer right here. It's the same logic we did over here. We took 10, left at the base, put that there and here. 10 to the x power is 100. 5 to the fourth power is this. And now we're back to just some algebra, right? Now it's a two-step algebra. Add this over here, 629. Divide by negative 5. And there you have it on your answer choice. That's choice B. For your homework, I will collect your work. I don't need this worksheet printed, or I don't need it at all. Number 2, same deal. Well, if you go back up here, this is the important step right here. We're converting from logs to exponents. All right, let's do this math. Add this over here. We have 0. 5 log base 2 negative 9a plus 7, 0. Divide by 5. 0. All right, let's leave logs and convert to exponentials. This is 2 to the 0 power equals negative 9a plus 7. That's 1. Any number to the 0 power is 1. And now subtract this over here is negative 6. Divide by negative 9 is 2/3 positive. Reduce that fraction. We have that there. All right, number 3, same deal. Let's go ahead and draw a line down the middle. Add this over and divide by 5. Can I do those 2 steps in one? What would that be? That'd be 9. Whoops, this is supposed to be a negative 7, I believe. That's a negative 5. It was a negative 7 in the problem. That'd be a negative, let's just do it one step at a time. Negative 5 log 3, 6n minus 7. That's a negative 1. Leave logs, go to exponents. That is 3 to the negative 1, 6n minus 7. What is this? Well, that's 1/3. And now I'm going to multiply both sides of my equation by 3. That will be 1 is equal to 18n minus 21. I just put this step in here because this step will clear out the fractions for you. It's easier to work without fractions. Add the 22, divide by the 18, reduce that 11/9. And that is also letter B. All right, last problem that I want to talk about, number 11. Same problem, nothing. Add this over here. Let's see here, what is that? 4 log 9 plus 8. Try and keep your lines real nice and neat. It's easier to avoid mistakes if your work is neat. Divide this over here. 2. The problem is we don't have a base here. The convention we're going to use is if there is no base, it is 10. I know a lot of times we put 1s, but in the world of logs, base 10 is a common one. Your calculator will do base 10 later when we start doing them. So we'll call it base 10. And again, 10 to the second is 9n plus 8. If you forget this step, the key is go with this letter E. 10 to the second power is that. It always helps me remember it. Now you just have to solve that equation like normal. That's 100. Add that over there and divide. All right, I hope this helps. We are working with logs and exponents. They're both related. This problem asks, what is 2 to the 3rd power? This one asks, what exponent do I need to go from 2 up to 8? All right, I hope this helps with your homework.